Hello, welcome to Black Holes Don't Exist. In this program, I'll be discussing, in general, why I think black holes don't exist. I welcome evidence from anyone who wants to prove or disprove the existence of black holes. In this program, we'll be looking at pictures of our galactic and universal neighborhood. We'll be searching for black holes starting at the center of our galaxy, and then we'll move on to other galaxies suspected of having black holes within them. But before I get into my own history about what got me into studying black holes, I want to start off by trying to get an answer about black hole discovery. So, in this first episode of Black Holes Don't Exist, we'll be mainly looking at pictures of supposed black holes, and we'll be comparing those to artists' depictions of black holes. What are black holes? Well, I thought I'd be witty and search on a popular internet search engine for the words, first known depiction of a black hole. The first link on the top of the list was called Discovery of the First Black Hole. Clicking on this, I was taken to a page from NASA's Goddard Space Flight Center. So, this is an official page from what is supposed to be the U.S.'s top space organization and probably the most informed independent scientific entity in the world. I see a question and answer in this section of the website called Ask an Astrophysicist. The question was, who was the first person to discover a black hole and what was the date? Paul Butterworth's answer for NASA was, black holes cannot be observed directly and therefore cannot be discovered. However, as we explain at our website, the indirect evidence for two kinds of black hole is now overwhelming. Those of us few solar masses produced by supernova and much larger ones at the center of some galaxies. I'm confused. Is it possible to detect anything indirectly via science? We'll talk more about this later. So, I continued looking down my list, and I find this page, No Escape the Truth About Black Holes, from teachers Paula Berinsky-Hendry and Greg Helms. Now, this is very compelling. I should find a good depiction, or maybe the first depiction of a black hole. Well, I did find information about the first black hole theory. Using Newton's laws in the late 1790s, John Michell of England and Pierre Laplace of France independently suggested the existence of an invisible star. Michell and Laplace calculated the mass and size, which is now called the event horizon, that an object needs in order to have an escape velocity greater than the speed of light. In 1967, John Wheeler, an American theoretical physicist, applied the term black hole to these collapsed objects. So, on this page, the teachers answer the question, number 6, do all stars become black holes? Their answer is, only stars with very large masses can become black holes. Our sun, for example, is not massive enough to become a black hole. They also go on to answer the question, number 9, what evidence do we have for the existence of black holes? They say, astronomers have found convincing evidence for a supermassive black hole in the center of the giant elliptical galaxy M87. We're going to take a look at the compelling evidence of M87 a bit later in this program. Before we get to that, let's stop skipping ahead of ourselves and get to the nitty-gritty. What is a black hole? According to the Free Dictionary, black hole in astronomy is a celestial object of such extremely intense gravity that it attracts everything near it, and in some instances prevents everything, including light, from escaping. The term was first used in reference to a star in the last phases of gravitational collapse by the American physicist John A. Wheeler. Gravitational collapse begins when a star has depleted its steady sources of nuclear energy and can no longer produce the expansive force, a result of normal gas pressure. As the star shrinks in size and increases in density, it may assume one of several forms depending upon its mass. A less massive star may become a white dwarf, while a more massive one would become a supernova. If the mass is less than 3 times that of the Sun, it will then form a neutron star. Extremely small, extremely dense star, about double the sun's mass, but only a few kilometers in radius. However, if the final mass of the remaining stellar core is more than 3 solar masses, as shown by the American physicists J. Robert Oppenheimer and Hartland S. Snyder in 1939, nothing remains to prevent the star from collapsing without limit to an indefinitely small size and infinitely large density, a point called the singularity. Okay, so I think we've figured out what a black hole is. Or have we? What have we learned about black holes so far? In order to find out what black holes are, we need to know what we're looking for. Number 1, black holes can't be observed, therefore they can't be discovered. This makes it very impractical if you ever try to go looking for one directly. This is when they laugh at you for being crazy. Now you can't possibly find something you can't see or detect directly. Number 2, black holes need to have an escape velocity greater than the speed of light. This means that it's not a black hole if light is escaping it. We'll be going into it a bit later about who came up with the light speed limit. 3. Everything, including light, cannot escape. This basically means all matter discovered and undiscovered, and all energy, including photons, cannot escape. I assume by the term everything, this also includes space and time itself. Therefore, if anything is allowed to escape, it would be contradictive. Number 4, the remaining stellar core of a collapsing star must be larger than 3 solar masses to form a black hole. Now, this caught me off guard when I first heard this. If this is true, that may mean that out of the hundreds of millions of stars in our galaxy alone, all of which have solar masses averaging from our Sun to 300 times plus, around 99% of all these stars in our galaxy should become black holes. Wow. Now, these 4 criteria aren't the only criteria, but they're basically the proper description of what a black hole is. You can figure out what it does from these criteria. Very radical. Now that I filled your head with enough information from just a few links I discovered on the internet about black holes, you should be starting to form an opinion about the theory yourself. Please forgive me if I broke your head. I didn't make this stuff up though, but wait, there's more. I've been showing you artist drawings, paintings, and 3D renderings of black holes throughout this program, and I technically only revealed one piece of evidence. It's time for the segment of this program where we go over photographic evidence for black holes. For this episode of Black Holes Don't Exist, I have prepared almost 10 pieces of photographic evidence provided by telescopes like Hubble. Not only does this evidence seem to support black hole theory, it also seems to disprove it, as some of the observable phenomenon doesn't match up to the artist's depiction, as well as the scientific measurements of some data reveals that the universe is breaking the laws of physics. Our first pieces of evidence in this segment is the core of the galaxy NGC 4261. These photos were featured in Life magazine and are courtesy of Hubble Space Telescope. Notice how different this photograph is compared to the artist's depictions you have seen previously. Granted, when we look up close, as is featured in this photo, we see an accretion disk and some kind of funnel formation occurring perpendicular to the radial axis of the disk. This is producing the jets of material escaping the proposed black hole. This next picture is of a gamma-ray burst, GRB 100621A. This was so bright that the astronomers at NASA's Swift Space Observatory initially threw out the data because they thought it was junk data, like it wasn't true. After weeks of checking and double-checking the figures, the astronomers were convinced that this wasn't an error, but that doesn't mean that they really understand what caused it, as lead researcher Neil Gorels explains. We're trying to grapple with what happened here. The best thinking is that it was still a burst of a black hole, but when this particular black hole was born, there was something particularly violent going on in the outflow. Here's an image of NGC 5128. This was first observed by Chandra in September 1999 and is also known as Centaurus A. It was an early demonstration of what spectacular science this powerful X-ray observatory could do. Astronomers continue to use Chandra to study the elliptical galaxy also known as NGC 5128. This galaxy contains a spectacular jet and a core teeming with X-ray emitting sources. This galaxy is in the M83 group of galaxies. It is said to be one of the most interesting and peculiar galaxies in the sky, and is a strong source of radio radiation. Therefore it is designated Centaurus A, the nearest radio galaxy. It is of an intermediate type between elliptical and disk spiral galaxies. The main body has all the characteristics of a large elliptical but a pronounced dust belt, and is superposed well over the center, forming a disk plane around the galaxy. This is information from Hartmut Frommert and Christine Kronberg. Another image that's said to be showing a black hole is this evidence for recoiling black hole. This black hole was found using data from Chandra, colored in blue in this composite image, Hubble in gold, and XMM Newton and several other ground-based telescopes. Astronomers are said to have discovered the recoiling black hole called CID-42 while conducting a large multi-wavelength survey called the Cosmic Evolution Survey, COSMOS. This black hole is in a galaxy approximately 3.9 million light-years away. This next image is of R136AL. This is a blue hypergiant star, currently on record as the most massive star known, at an estimated 265 solar masses. This star is also called a black hole for some reason. The star also holds the record for the most luminous at 8,700,000 times the luminosity of the Sun. It is a member of R136, a superstar cluster near the center of the 30 Doradus complex, also known as the Tarantula Nebula, in the Large Magellanic Cloud. The mass of the star was determined by astronomers at the University of Sheffield. Now for one of the most compelling evidence for black holes. However, this won't make most black hole believers happy when they realize that Hubble Space Telescope measurements mean this jet being emitted from M87 is moving faster than light. Of course, this fact doesn't disprove black hole existence, it disproves a law of relativity. This has a domino effect on physics because the very law we are talking about, the light speed barrier, is used to define measurements of black hole activity. What I'm about to show you is going to blow your mind. This sequence of Hubble images showing apparent motion at 6 times the speed of light in the galaxy M87. This jet is about 5,000 light-years long. The boxes in the next sequence of images indicates where the superluminal motions were seen. These Hubble images show motion at 6 times the speed of light. The slanting lines track the moving features, and the speeds are given in units of the velocity of light, c. The images were made between 1994 and 1998 with a faint object camera on the Hubble Space Telescope. The photo credits from John Breda of the Space Telescope Science Institute. Our final pieces of evidence come from observations of the center of our own galaxy. This next series of photographs show that there is something very peculiar going on in an area of space some 27,000 light-years away. A team of astronomers has reported evidence in 2002 that a supermassive black hole lives at the center of the Milky Way. For a decade before then, researchers were watching a handful of stars at the galaxy's center, waiting for one to swerve. They found a star whose telltale orbit could have only been explained by the pull of a black hole. Scientists claim that there is a very heavy object here, something weighing 3.5 million times as much as the Sun. In order to prove it was a black hole, the team from Germany's Max Planck Institute for Extraterrestrial Physics has to show that all of the material is packed into a very small space. And one way to do this is by watching the stars around it. Here's a well-known animation of the stars moving around the galactic center. Notice that where they are pivoting there is no observable phenomenon. Instead, they use a red plus marker here. Therefore, naturally, one would think that there would be a black hole there, right? Since we can't observe it directly? Their theory seems to hold up. I still have my doubts, though. In this photograph, the final in our series, called Radio Arc 450, is supposed to be a very clear picture of a black hole at the center of our galaxy. This image is credit to Farhad Yousefzadeh et al., Northwestern VLA, NRAO. A supermassive black hole is thought to be hidden inside this bright source at the center of our galaxy. We have looked at several artist depictions of black holes. We have alleged evidence of their existence with photographs. Why do the artist renderings in most cases look alien compared to the photographs? We've talked about the black holes that are supposed to be. We learned that they can't be discovered yet, but we can take photographs and argue Join me next time in the next episode of Black Holes Don't Exist, where I go over a little bit more about the history and the technicalities of black holes and exactly why I think it's absurd that anyone ever wasted their time trying to discover them.